So this is example 1 part 3 that we started in another video, and I just wanted to kind of remind you that square root of x is x to the 1/2 and the cube root of x is x to the 1/3, and we are going to be doing a product rule. Why is the square root of x and the cube root of x the way we mentioned? It's because of the rule that says the nth root of a to the m is a to the m divided by n. So we can rewrite the square root of x if we wanted to as x to the power of 1/2. That's because there's a 1 that's invisible and a 2 that's invisible. Also, the cube root of x can be written as x to the power of 1/3 because of the 1 that's invisible and the 3 that's in the index. So at least we know how to convert the notation, and we need to know how to do this because we want to use the power rule in the next few steps. And again, this is a product. Right there, there's a little dot in the middle, and we're multiplying x's with other x's. So we need to set it up like a product rule. Let's figure out who the first function is, who the second function is. So the first function is square root of x minus 3, which we're rewriting as x to the 1/2 minus 3. The second function is the cube root of x plus 2, which is the same thing as the x to the power of 1/3 plus 2. So those are my first and second function, and now I need to know the derivatives of each one of those. So it's easier to differentiate x to the 1/2 minus 3, and the derivative of that is going to be 1/2 x to the power of -1/2, and the derivative of 3 is nothing, it's just going to be 0. Similarly, the derivative of x to the power of 1/3 is going to be 1/3 x to the power of -2/3, and the derivative of 2 is going to be 0, so we can just ignore that. So that's basically the start. So at this point, we are expected to multiply the corners according to the product rule. And the product rule basically says start with the 1' corner, go around, multiply everything, and in the middle, put a plus. So we're multiplying the 1/2 x to the -1/2 with the x to the power of 1/3 plus 2. Also, we're multiplying the 1/3 x to the power of -2/3 with x to the 1/2 minus 3. Now, when you're multiplying, you have to be a little bit careful because when you multiply bases with different exponents, so like for example, a to the m multiplied by a to the n, the rule of the exponents basically says you are expected to add the exponents. A lot of people multiply the multiply the exponents with one another, and that's not true. You're supposed to add the exponents. So just be careful. We're going to be adding -1/2 with 1/3. You can use a calculator for that. We're also going to be adding -2/3 with 1/2. So again, be careful when you're multiplying, and the bases when they're x's, you have to add the exponents, and you can do that with a calculator. Also, when you're multiplying the 1/2 x to the power of -1/2 with the 2, the 1/2 and the 2 cancels out, we just get the x back. Similarly, the same thing happens when you're multiplying 1/3 x to the -2/3 with the -3. The 3 and the 1/3 cancels out, we just get the x term back. And at this point, you're going to look for like terms, and it seems like we have a couple of like terms in this problem, so we're going to add them up together. So there's 1/2 and 1/3 right there. We're going to add them and basically be finished with this whole thing. So 1/2 plus 1/3 is 5/6, x to the -1/6. And we also have the x to the -1/2, and finally x to the power of -2/3 with the negative in front of it. So you can kind of rewrite the expression with radicals and with the positive exponents and whatever, but I'm not going to be doing that. This is good enough for now, and we'll just stop, especially because we're not doing anything else with this particular problem afterwards.